Okay, so tell me what we did in the last class. Is it eigenvalues, eigenvectors? Eigenvalues. Whether eigenvectors is done?
Ma'am, Cayley-Hamilton theorem.
Cayley-Hamilton theorem is done. Means we have done till eigenvalues. And based on eigenvalues, means the characteristic equation, we continued with the Cayley-Hamilton theorem. Okay. Now, let us learn how to find eigenvectors today. Okay, how many students have joined? Yes, 35 students. Okay. So let me tell you what is the procedure to find out the eigenvectors. Now see what happens, students. Tell me if you can see clearly here. To find eigenvectors. Is it readable, students? Is it readable? You can put in chat box. Yes, no, whatever. No. Is it blur? Is it blur for everybody? Isham, what is that? Yes, ma'am. Is it clear or? Okay. So I need to adjust the height, you mean to say? Okay. See, tell me about the height. If this height, if I take, then is it okay? Now is it readable, students? At this height? Or still it is blurred? Okay, like. Pradyumna is saying okay, like. What about this? Tell me fast. Yes, no, whatever. Black screen? My God.
On the page is also not straight.
find the eigenvectors. I'm going to give you steps. Okay. So this is the extension of your eigenvalues. Now the first step is like this, students. First step is find voice is breaking. Find eigenvalues find eigenvalues. Is it okay now, students? Find eigenvalues. It's not clear.
Ma'am, continue and send pics in the group.
Okay. I don't know. I don't know what is happening. Okay. Okay, so question is eigenvalues and eigenvectors. What you have to do is you have to write the first step is find eigenvalues. I'll dictate. You can dictate. I'll send the pictures also to find the eigenvalues of given matrix. Given matrix A. So last time, as I told you, the method to find the eigen, same method you have to follow. Okay, done. Have you written down the first step, students? Step 1 is find eigenvalues of a given matrix A. This is your first step. Now the second step is write the matrix equation. Write the matrix equation A minus lambda I x is equal to O. I repeat, second step, write the matrix equation A minus lambda I bracket complete x outside equal to 0. This is the second step. Okay. Tell me if you want me to dictate again, please. Till here it's okay, students? Now step number 3. Step number 3 is substitute all eigenvalues. Substitute all eigenvalues one by one in the above matrix equation. See, students, what I'm saying? Substitute all eigenvalues. Substitute all eigenvalues one by one in the equation. Now next step, step number 4. solving the above equation, we get eigenvector for each eigen value. I repeat the last step, students. Solving the above equation, we get eigenvector for each eigen value. Okay. Could you write, students? Please tell me in chat box. Could you write this? Yes, okay. Thank you. Okay. So these are the steps, students, which I will follow to find out eigenvectors, right? Now let us solve one example to find the eigen values as well as eigenvectors, because unless and until you find eigenvalues, you will not be able to find the eigenvectors, right? So let us solve the example, students. Take down the problem like this. Example. So these examples come in exam for at around 7 to 8 marks. Question is like this. Find the eigenvalues and eigenvectors of the matrix A equal to the matrix is given as 3, 1, 4, 0, 2, 6, 0, 0, 5. Okay. See, I repeat the question. Find the eigenvalues and eigenvectors of the matrix A equal to, the first row is 3, 1, 4, second row is 0, 2, 6, and third row is 0, 0, 5. Okay, students? Okay. Now, which are the steps here to follow? The steps are given here. The first step is find the eigenvalues of the given matrix, right? Okay. So, let us find the eigenvalues, students. Now, see, this is the matrix of order 3 by 3 because it contains 3 rows and 3 columns, right? So, what we do, students, here, we use the shortcut method to find out the eigenvalues. It becomes easier. So, do you remember the shortcut method, students, which I taught you in the last class? It directly gives us the characteristic equation, which can be solved on the calculator to get the eigenvalues. So, first term is lambda cube. Alternate changes in the signs, if you remember, minus sum of the diagonal elements, that is 3 plus 2 plus 5 lambda square, plus, put the bracket, then we put the 3 minus first 4 numbers plus last 4 numbers plus corner numbers. And this is what, students? It is coefficient of lambda, and minus determinant of the given matrix, and is equal to 0. Should I repeat, students, or you can see a little bit now? Is it little improvement in the view and the sound? Yes, it's clear. Thank you very much. Okay. So this is the characteristic equation I told you last time. Correct? Now, solve it and see what is your characteristic equation? Now let us do it. Lambda cube plus 10 lambda square, right? Now here it will be minus, students, because the alternate changes in the signs are inbuilt in the shortcut formula. Plus. Now when you do plus, students, no need to increase the number of steps. Here itself you can do some rough work. See, 3 2s are 6. 6 minus 0 will be 6. So value of this minor is 6, right? Then this is 5 2s are 10. And cross multiplication will be 0. So this 6 plus 10, 5 3s are 15, right? And minus 0. So how much it becomes? See, 15 plus 10 is 25. 25 plus 6 is 31, right? 31 lambda plus, because plus is the inbuilt sign. You can do by yourself and tell me if I'm doing any error. Minus. Now students, I told you to find out the value of the determinant on the calculator directly, because I had sent you the video of the operations on the calculator of matrices, right? So see if you can find out the value of determinant on calculator directly instead of doing it manually, and tell me if you get the value.
Ma'am, it's 30.
30 plus positive 30 or negative 30?
Positive.
Positive 30. Anybody else got? Have you studied, students, how to use matrix operations on calculator? First of all, tell me.
30, ma'am.
30. Okay. Because it is very important to save the time, because these are all big examples. Even if it looks easy, a single sign mistake will give you wrong answer. Okay. So for the accuracy and time saving purpose, please learn matrix operations on your calculator. So for every model, the matrix operations are available. What you can do is either watch the video which I have sent you. If you have some other model, then put it on the Google, the manual of that particular model. Step by step, everything is given. Okay. So directly you get 30 instead of doing manually. So this is what, students, this is your characteristic equation, right? So hope everybody is getting why this minus sign is coming, because it is inbuilt in the formula. Alternate changes in the signs in the shortcut method, plus, minus, and minus. Okay. Suppose value of the determinant is negative, then minus will become plus, students, that you remember. Okay. Now again calculator comes into the picture. You can solve this equation on equation mode of the calculator. How many roots you should get, students? Arbas, can you tell me? Yes, Riva is saying 3. Very good, because it is a cubic equation, no? So you have to get 3 roots. So can you do it quickly and tell me what are the roots?
5, 3, and 2.
5, 3, and 2. What about other students? Please put on chat box what are your roots you are getting, so that I'll come to know that everybody is doing. What are roots you are getting? Put on chat box. If anybody needs help on the this calculator usage, please tell me. Right? You first watch the videos, check the manual online, and still if you have any doubt, if you are not understanding, then let me know. Okay. Yes. So many students are getting 5, 3, 2. So I'm writing here the roots. Lambda is equal to 5, 3, 2 or 2, 3, 5. Order is not important, as I told you, students. Any number you can write at first, right? Now till here you know what we have done, right? Because this is just the first step to find out the eigen vectors. We got the eigenvalues, right? Now, before going to eigen vectors directly, I need to tell you few things about the eigenvectors, right? So, it is called as properties of eigenvectors. So, keeping these properties in mind, you can proceed to find eigenvectors. Now, the first and the important property is, students, the eigenvector x is not unique. I repeat, the eigenvector capital X of matrix A is not unique. This is very important. But eigenvalues are unique. Okay. Second property is eigenvector is never 0, 0, 0. Okay. Or instead of writing 3 zeros, you write directly 0. Or the null matrix, in place of 0, we'll call it as O, means the null matrix. Because vector is a matrix itself. Either it is a row matrix or a column matrix, right? So what I said here in the second step, see students, eigenvector is never null matrix or the null vector. This is O. So you should not get all zeros in the eigenvector. This is the second property, right? Okay. Now the third property is, for every eigenvalue, we get, corresponding eigenvector. For every eigenvalue, we get corresponding eigenvector. Okay. Is that clear, students? Could you write? Should I proceed? Okay. Now let us continue with the problem. So these are the properties, correct? Now continuation of the problem, your step number 2. What is step number 2, students? To find eigenvectors. How many eigenvectors you should get, students? 3, because there are 3 eigenvalues, right? Okay. Now to find eigenvectors, what is the step I told you, students? If you read the steps, you have to write the, yes, ma'am, we have next lecture in 10 minutes. My class was at 9:30 to 10:30, right, students?
No, it was 9:50.
Okay, it was changed, right? Okay, that's why. Okay, so we'll continue in the next class, students. Okay, because you have class immediately, no? Sorry for delay. Okay. Will you give the attendance quickly, students? Give 1. Type your numbers fast. 1, 2. Arey Baba, 43. Why? 1, 2, 3. 3 is absent. 4, 5, 6, 7. 7 is absent. 8. 8 is absent. 9, 10, 11, 12, 13, 12 is absent, 13, 14,
Ma'am, I'm present.
number 12, okay,
Roll number 8. 8.
8, okay, 12, 13, 14, 15, 16, 16, absent, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27, 28, 29, 27 is present, 29, 30, 31, 32, 32, 33, 34, 34 is not there, 35, 36, 37, 38, 39, 40, 40, 41, 42, 42, 43, 44, sorry, done. Okay, thank you very much, and I'm very sorry for delay of the class and for the inconvenience. Next time we'll continue with the same problem. Bye.